an Uber, and it took the driver to arrive to pick me up like 22 minutes.
Yeah.
And he was like swearing all the time. He was like, "This is broken, it's so bad." It's like,
Oh, my Uber went like on time, perfect. The guy drove like a stolen car. I felt like we were about to crash like twice. So I think we were here like 2 minutes early. Honestly,
Oh, wow.
it was kind of amazing. Sit down.
Are we starting?
Yeah.
Is it already? It's not past, or do you want to start?
No, I have to start earlier, right? And then you start at past. Yeah. Yep. We're almost time, right? Is this on? Do you think it's blue?
It's blue.
I checked last. Okay. All right, I think we're set. Yeah. All right, guys, welcome. Hi, good evening. I'm Benazir. I'm a community program manager at Microsoft. I just wanted to give us a quick rundown of the Kubernetes and cloud native meetups as we've been having it for some time. First of all, welcome. Thank you for making it. So glad you're here. And yeah, I'd start with a quick round of applause to all of you who made it. Yeah, despite all odds for today. I just wanted to kind of go over a little bit of the history of the meetups and since when we've been doing it and how we've been doing it and how far along we've come and where we plan to go ahead with it. So Meetup started out as cloud native computing meetups in Berlin in 2016 with a team called Kinfolk and a company called Kinfolk, which is now part of Microsoft. The folks that also started the meetup were also consistently doing it, running it over time. And then, of course, the pandemic hit. And post-pandemic, that's when I really came into the picture, and we kind of relaunched and rebranded it, and now it's part of the Kubernetes and Cloud Native Berlin Meetup group as we know it. And the reason for that was to kind of combine two large groups, which was the Kubernetes groups in Berlin and the Cloud Native group, and kind of merge them together so that we have more to talk about and more topics in the mix and more speakers in both communities. And just kind of have meetups which are, good points of intersection for both communities and where both communities can exchange ideas and give talks and learn from each other. So yeah, I also wanted to highlight the fact that we will keep continuing to host these meetups. Of course, the cadence this year is bi-monthly. I've discussed this even in the last meetup, the first meetup of 2024, which was in January. So the interesting part was this was supposed to be a March meetup, but it is a leap year. So we came at this planning decision, we arrived at this planning decision with the Mercedes-Benz IO folks and decided that, well, it is not a bad idea if it's a leap year to have it on Feb 29 anyway. So here we are, and thank you for making it again. Please reach out to me. That's my email and that's my LinkedIn. If you have any thoughts or ideas on co-hosting or co-organizing a meetup, we're doing a few of these meetups at the Mercedes-Benz IO office, but I'm also open to chatting about how we could do it potentially at any of your office venues. And yeah, let's have a conversation. And yes, I wanted to emphasize on a very important and a very crucial part of the meetup, which is the code of conduct. We're all pretty mature about all of this stuff, and we're very professional, but it's always good to emphasize that we're dedicated to providing a harassment-free atmosphere and an ecosystem where everyone can actually keep coming and keep discussing different topics and exchange ideas. And it's all right to disagree. Let's just be polite and cordial about it and agree to disagree where it matters. And yeah, let's be cordial about it. That's it. And yeah, I just wanted to share a few moments from the previous meetups. You might remember some of these moments. This was at the last Kinfolk office. Some of those images are also from the Kinfolk office. That's one of our speakers earlier. This was our first meetup in January right here. That's Thilo speaking. That's another meetup that we had. I think that was the last meetup at the Kinfolk office. So nostalgic times from back then, but we have to keep evolving, and we're happy to do that, and I'm just happy to continue to host meetups at all of these different offices. And coming to which, big thanks to the Mercedes-Benz IO folks for allowing us to use this office space to host meetups. I think it's pretty cool. And you all made your way through the treasure hunt that was from Spindler's Hof to here. So crossing 2 hofs and making it all the way. And I assure you, we will keep continuing to do this for April as well as June in this office. And we'll announce the dates for those meetups also pretty quickly. But yeah, glad you're here, glad you enjoyed it. These are just some glimpses of past meetups that we did. As you can see, we've had 7 successful meetups so far. I don't want to jinx it, but this is the 8th meetup, and I will talk about it in the next one, so we can also kind of applaud and celebrate ourselves for being a community and coming together and gathering and chatting about all of this stuff. And since the relaunch, the new meetups that were the Kubernetes and the cloud native meetups to bring both groups together started on December 8th of 2022. That was the first one. We had a huge number of attendees. I don't know if some of you actually came to the Kinfolk office and have seen that loft. It was huge, and at some point, I really did think that 142 attendees is almost like a mini event. I do consider that to be a mini event, and we've had anything from that number to about 60 or 40, which is a good number, a good size for a meetup, I think. And continuing on, that's kind of how we want to see it. We want to, encourage you to also, no problem. We also want to encourage you to chat with friends and colleagues in the industry and let them know about the meetup. And yeah, there's always going to be the event pages, but subscribe to, the meetup page, and they will be able to know better about the meetups that we're hosting going forward. And also, yes, thanks to Fiberplane for sponsoring the pizzas today. I know it sounds like, we're kind of, this is something that we do over and over with a cadence, but every little bit counts, and this is kind of a huge community giving activity. So anytime some of these companies come together, we're able to actually organize meetups for you guys. So if your company is interested in sponsoring pizzas or refreshments at any point of time, you want to host it at your venue, your office space as a venue, or a co-working location that you know of as part of your office, let's have a chat. Happy to do it. We're happy to diversify the venues so that everyone feels like they can participate and feels invested in the organizing of these meetups. And yeah, finally, while, again, a big thank you to Mercedes-Benz for the venue and Fiberplane for the pizzas. And going forward, just want to shed some light on Cloud Native Rejects, which is a conference that I organize. And we're part of a small organizing team in Microsoft, also the Kinfolk team in Microsoft that organizes Cloud Native Rejects. And this is happening before KubeCon EU, and quite soon, actually. March 17, 18 seems like, yeah, it's still a few weeks away. It comes in a blink of an eye. So I've been saying this to my organizing team internally as well, and I'll reiterate to you. For some of you who do know Cloud Native Rejects, because this was also something that was started by the Kinfolk team a while ago, and it's something that I run and primarily organize now. For some of you who do know it, the concept is basically to give a stage or a platform to rejected talks from KubeCon. And we had a lot of proposals, of course, for this iteration as well. But the talks that did make it are in the schedule, and you can come and ask me about the schedule later. I just want to shed light on this and say that if you are getting to Paris before KubeCon, you have registered for it. We're at full capacity. So there's no way I can actually sing gaga and be gaga about the fact that register now. We're at full capacity, but just wanted to say that those of you who do know, and I know a lot of you have attended it as well. So if you've attended it before and you've registered for this iteration, we look forward to meeting you. It's going to be a lot of fun. I was chatting with Neela earlier, who's also going to be at Cloud Native Reject. So some of us are here to talk about what a fun event it is. And it's a great conference to recycle your rejected KubeCon talks. And yeah, with that, I'm I will give way to Neela, who's our first speaker for the evening. And Neela will actually talk about a lot of fun stuff with an analogy of a Rubik's Cube, which is solving incidents collaboratively. So I'll yield the floor to Neela. Please, big round of applause.
I need this. Okay. Yeah, funny enough, I entered today the office here and I saw all those Rubik's Cubes in the office and I was like, that's good. I'm arriving at the spot for this talk. I have to make a disclaimer. I've never solved one of those, but still I think, you will get the idea why if we talk about complex systems, we can talk about Rubik's Cubes. And I like to give a little bit of a background where I'm coming from. So in my first job, I was really more working on the side of a backend engineer, but not as an engineer, more as a consultant. But it was all about like, how we decompose systems into those called smaller services, microservices. And that was great because you reduce the complexity of those services, so the code within the services can stay quite small. But where you add complexity basically is in the communication or in the invocation of those services, because you no longer, if you consider microservices in that way, you sometimes have this direct invocation via HTTP from service to service, but nowadays I think we know if we are in those architectures, we work with message brokers, with Kafka, with RabbitMQ to have them loosely coupled, and that adds more complex patterns when it comes to communication and also makes it harder really to understand how the flow in our system goes. So also if you now think I want to have maybe some tracing here, it gets quite interesting because you also have to trace the message broker and so on. And also, it seems like, okay, that maybe is already the one thing that we have, but then considering also the infrastructure we run nowadays, we have a different layer, and this layer also is complex. So if you look at a Kubernetes setup, you will have your services in different pods. Maybe even you have at some services a sidecar attached, and the message broker also runs in your clusters, and or connecting to the API server. And I think that gets quite interesting when we talk about incident handling because, it's often not enough to look at at one component, but they are all interrelated with each other. And sometimes I would call it hidden causality. One of the incidents, we think, oh, it must be that one. And then once we start digging deep, we discover it's a completely different thing we haven't thought about. And that's how we learn more about our systems. Yeah. That's me. Bernice already announced. I work for Fiberplane. Before I worked for Camunda, that was the story about the microservice orchestration. And now with Fiberplane, we build notebooks to collaboratively debug infrastructure. And I switched more on the side of topics that handle DevOps and SRE topics. Funnily enough, we sponsored the pizza today. We were talking about a notebook integration to call your favorite pizza service as soon as an incident arrives. So you open a notebook and the notebook takes care of your pizza for handling it, but that's more a fun project on the side in the company at the moment, but I thought it fits quite well. So let's come to the Rubik's Cube. Why do I think it's a good analogy for it? I think when we talk about software, we have these different sides of our system. We have the backend engineering side that takes care of the server logic. And those engineers, normally, they live in their IDE. I put various here. You can even think in an organization, you might have one language, but you have multiple, and then you're more handling or you're more in a polyglot system. And then, of course, we also have the side where the SRE team maybe sits and where people monitor your systems and add observability, and those live in different tools. They normally look at tools like Prometheus, like Jaeger, connect them to Grafana for the monitoring, but also live a lot in their shell and do a lot here. Just out of interest for you folks, who lives on this side of the cube? Like who is in the SRE DevOps space? Kind of, and maybe not this side of the cube, but there are other tools you might even consider that are not in there. Yeah, I mean, that's also completely fine. Someone living on the backend engineering side of things? One person, two. Cool. And yeah, I mean, as said, there are multiple sides of the cube and different things. And I think when it comes to an incident, we need to look at all of them. And then there are some common tools, I would say, that every engineering team knows. For example, OpenTelemetry is important, especially when it comes to the journey of instrumenting backend applications and make them observable, because it's a direct connection from the backend engineering to observability teams or SRE teams. And I put it here on the white side because they're not necessarily at collaboration, but it's a tool that is known by multiple teams. And as said, also the other sides. And when we consider an incident, what happens to our system? Well, it's out of order. It's not in the state that we define it to be. So we kind of need to fix that. And when we talk about incident handling, we have normally those 3 phases. And of course, if something is completely out of order, everyone in a company normally agrees on this. We need to fix this as soon as possible. We need to bring it back so we can function as we want to, or as we have defined it. So in the first phase, we talk about resolving it. I think the interesting part here is that if you start resolving it, you look automatically at the terms of causality and what has gone through your system. And considering different teams, they might have different approaches to that, because there are different tools helping us to understand causality. So if we talk classically about observability, I might look into a tool like Zipkin or Jaeger with my traces, and I try to understand the call chain basically of different functions, of different activities, and I try to see if I can detect some latency in one of those to see what is broken. But I could also look into tools, for example, like Istio, if I have it as a service mesh running, because Istio also provides a call graph. And also a call graph gives me interesting insight into causality and how different services might be called in that order. And if I'm a backend engineer and I work with this messaging broker thing, I might also maybe work with workflow orchestration or with service orchestration, and I have a workflow component, and then that could be something like that graphical, but there are also workflows in YAML or whatever. But I might have a slightly different view on how I look into causality, and I might have a different deepness of level. I don't think that one of those is better or than the other. I just think it's interesting that we find causality in different tools nowadays when we talk about software. And when we have an incident, we need to understand the causality in order to fix the error. And I think the most important part is that not every team looks at their different views, but that we start creating a common understanding. So we bring basically everyone to the same page. I put here Fiberplane notebook. I mean, I work for Fiberplane, but it's basically the idea to bring everyone to the same page to collaboratively debug. But you can also consider that your Slack channel, where you have maybe your incident channel open and you start putting your charts and your graphics and start discussing what's going on. And then in the second phase, of course, once we understand the underlying problem, we try obviously to fix it, and we might have different strategies already defined. Can be sometimes very basic, so putting them here like retry, restarts, or bringing back an old version, just in order to make sure we can function as normal and as wished. And then also on the tool side, what is interesting is here, what helps us in resolving incidents is defining good workflows. So defining maybe from the alert what should happen next, incident commanders and so on. So from PagerDuty, which channels do we open? Defining a good incident workflow can help us here and prepare teams to really collaborate actively together. The next thing is then, once we fixed the issue, and maybe we just did the retry thing, or we rolled back or rolled out an older version of our service, that means we haven't really prevented anything, or we haven't really looked into the real issue. So the next step would be, okay, we kind of fixed the version, or we fixed the service back to what it was. Let's look into ways how we can prevent it. With a Rubik's Cube, that would be quite easy, because I probably can glue it and then no one can move it anymore. With dynamic systems, probably not a good idea. But yeah, we have different things we might consider. It depends what happened with the incident. And also here, interesting enough, I think, for example, assume we had a call over a network, and let's just assume that some team forgot to implement a retry strategy. You can imagine that a non-implemented retry strategy could lead to an error, at least that needs to be handled. And also here, interesting enough, on different tool sites nowadays, we have different ways to implement retry. If I go and talk to an SRE person or a DevOps person, they might think directly of a service mesh where I can define a retry for the network call or for the shipping service just in my YAML. If I talk to the backend engineering team, they say, oh, I also can solve this. I just implement the retry within the backend logic directly. And I think it's not like one is bad, one is good. It's more like we have different choices and we need to be aware where we want to handle certain things. Do we want to have that in the service mesh? Do we want to have that in the backend code? And here the key is to have those rules clearly visible for the team and also make sure everyone understands where retries are happening. Because probably you also end up in a really weird situation if you implement retries in both tools and you don't know about it. So yeah, I mean, that's probably the part that everyone loves, documentation, but documentation helps to make sure you know in which tool you want to handle certain scenarios and certain things, because I think that's the thing with complex systems. We have more options nowadays to handle the same thing. And then, yeah, also consider, even if we have documented stuff and we've documented best practices, services and systems come in different shapes and colors. So just because the one thing is the best practice, that doesn't mean it works for all. And maybe consider looking for the options that work best for the specific service as well. And lastly, and I think that's a very important step, and that's at least from what I hear from people, it's not the easiest one. It's to discover your incident. So how is the alert going off at first? So how are we getting notified that we have a problem, that we have an incident? So how can we make our systems observable? And the answer to that is quite simple. It's telemetry data, so we can look at the logs, at the metrics and traces, and we correlate them. And obviously, if we have defined metrics, we can easily say, for example, if 99% is not reached, for example, we have 0.2 calls that are failing, like HTTP calls that are failing, we want to get an alert. So based on the metrics, we can get alerts. And then once we have the alert, we can use traces to see where is, for example, latency happening. So we can try to dig down. And then based on the log, we really see what's going on. But all those in combination, basically, the idea is to use them to understand what's going on in the system and also to make your system observable. And if we look into the architecture, well, in the process, how that could look like is, again, if we are looking at the application, we have the application sitting there with the application logic, and we have an observability data backend where we put like basically logs, traces, and metrics, and then on top, normally we have a query and alerting visualization platform. And the interesting part is basically when it comes to make the system observable, who is responsible for the instrumentation. We have the possibility nowadays to do auto instrumentation, but real value you get only out if you also see the business side of it. So you need to go into the application code often to instrument, for example, traces and not only the edges of your application. And then the idea is, okay, should a SRE or DevOps team be responsible for the instrumentation because they want to make the system observable, but then they are touching application code they are not in charge of. And I think that's an interesting discussion. Who is responsible really for instrumenting the code? And who is responsible for making that happen? And luckily, well, I say luckily, I think before open telemetry, that was even more a mess or even more complicated, because you can imagine that every observability data backend had own SDKs and own languages and own APIs to instrument the code. And once you wanted to switch one observability data backend, you really had also to switch on the code side, the SDK and the APIs. But now with OpenTelemetry, it's a better approach because it's actually trying to make it vendor neutral. So it provides those SDKs, those agents, those protocols in a neutral and vendor neutral way. And and it never aims to be a telemetry data backend. So you can decide which backend you want to put there, but theoretically, saying theoretically, because there are also some challenges, but theoretically you instrument here once, and then here you can basically switch and swap however you like. But then sometimes, that's why I say it's theoretically easy, but because also every observability data backend might have an own query language, and then again, you are a little bit binded, but yeah, it's a really good approach to make it easier. And it's also a CNCF project, and I think at the moment it's the one with the second most traction, so a lot of vendors are actually contributing to this one here. Out of interest, is someone using OpenTelemetry actively? Okay, cool. Yeah, as said, there are different approaches, but still, it's maybe not it's not taking away the decision and the ease of like how would you instrument, and so there might be still questions coming from application engineers. So, are you choosing the auto instrumentation? That means you have an agent next to your application running, and you don't need to touch your code base. But then also, you might not have everything you want from your application because you are only on the edges of the application. But then, if you do the manual instrumentation, maybe also what should I instrument now as a developer? Like what I'm interested in. And then also the question is, well, I have instrumented all my stuff, but now I have still the difficulty to write queries. So how can I also see something if I instrument it? I want to understand it quite quickly, and I don't want to go into Prometheus and write difficult PromQL queries, for example. And then also, in general, the question, how, if we instrument the code, how are those responsible for the SLOs and the ones that are triggering the alerts in the end that makes us awake and that say this is an incident. And last year, we've been working on those questions a little bit within the company. And we decided to create a framework. It's based on function-level metrics. So we say the things you want to instrument is basically the functions in your code base. So we go beyond those edges of the application, but we look at the functions. And it's called Autometrics. You can find it on GitHub. We have it available in different languages. And just that you see what it does is actually, it has the application code. It makes the instrumentation quite easy. It uses a wrapper around a function. We will see in a minute how that looks like in Python. Within your code base, you can define SLOs. And those SLOs, in general, the functions that you instrument are based on metrics. And the libraries also write the query for you. So you don't have to write a PromQL query, but you get the latency, the error, and the request rate of each function. And then this is stored in Prometheus, so you need to have a Prometheus instance running, and then you can decide where you want to visualize it. You can use the Autometrics Explorer that we've built for it. You can also use Prometheus if you want to, or you can even attach it to Grafana or any other visualization tool that you like. And the idea basically is to give you some metrics out of the box. And the really interesting part is, or I found it interesting because we also introduced a caller label. So with this basic metrics, we are also able to have a tracing light within our application. Because we have a caller label, we can see which function is calling another function, which gives us some traceability in the application, which is based on metrics, which is nice because a trace, or if you store traces, it's more, you need more space basically for it than you would do it with a metric because it's only a number. So yeah, let's look at the library. Just making it big here. So basically the idea quite simple. You import the Autometrics library into your app. And what you can do then is here, in terms of Python, you use a decorator over a definition. And here we have the get-to-dos with success and get-to-dos with errors. And if you hover over it, you already see the request rate, the error rate, and the latency. That's a IDE plugin. I can click on it, and it will bring me in a minute to the IDE to the front end where the applications or where the metrics are stored. And then also what I can do with it is basically I can define those SLOs in Codebase. So I can use the SLO API, for example, and say I have an objective here. I want 99% percent of my calls to be successful. And then in the decorator, I can give this objective, and then also this is represented in the metrics. So let's go to that point, for example, to the request rate. It's a long link, but yeah, that is the front end I'm talking about, and exactly here what you are seeing is the request rate, the error rate, and the latency. So we don't have any errors in this one, but you can see nicely how often it has been called, and also you could see potentially here call graph. This one is only the add to-dos. Maybe we need to go look at the get to-dos. That's the one that's more interesting. But here what we see, what I mean with the tracing light is, we see this endpoint actually get to-do was calling two other ones, the one with error and the one successfully, and even you could think if your application is a little bit more deep, you would even have more call graphs here. And the idea is really to make it easy to get those metrics for you, to understand them, also not only for production, but also when developing, because then also you can track some anomalies and stuff like that. Or maybe you have already a suspicion where something might be taking longer than you want it to be in terms of latency, and that's a way of getting track of this. And yeah, that was a short demo around it. Yeah, and then summing up, actually, when we talk about the incident handling process in total and the collaboration, I think the first step in resolving it is like having a tool on your hand that brings everyone to the same page, so you can collaboratively debug. Bringing everyone or creating this common understanding is key when you want to handle incidents. The second one is the documentation part and defining where things are happening in the application. For example, if you have multiple things like retries, where is retry implemented? And the last thing is basically about making the systems observable. And well, I mean, we've tried and played around a little bit with Autometrics because we think it can be an enabler for the part of instrumentation, and yeah, making that easier and closing a little bit the bridge between SRE teams and developer teams. But also, obviously, there are other parts and libraries that can help. But if you have any feedback to any of the tools, the notebooks, or also the Autometrics, we are always happy to chat. If you think that is completely useless, please reach out. We want to hear that. Well, we don't want to hear it, but we would like to hear feedback on any terms. And yeah. With that, I'm almost at the end, because I also like to announce one more thing. We know already Cloud Reject is happening before KubeCon. Also, we are going from Berlin with a train to KubeCon, and we actually choose a date for the train that will arrive on the 16th of March, hopefully, when Deutsche Bahn is doing all things good. So. In terms of like the ideas, we go all together so we can suffer in terms of the train all together if something is happening. And if you are interested in joining the train from Berlin to Paris, feel free to reach out to me or write an email to berlin@kubetrain.io. In Paris, we have a party with everyone traveling by train. And the idea behind that is basically make train traveling within Europe more attractive and not taking the plane. I'm quite excited for it, to be honest. I also like going on the train. If I have more people coming with me, that's great. And also, I think that is the one thing, it's hard to debug the Deutsche-German train system, so that's the one thing we might not resolve. But yeah, maybe we resolve our systems and our Rubik's Cube better the next time. Thank you.
Any questions? We have 5 minutes.
Yeah.
So the Autometrics solution, as I understood correctly, it has like a local or semi-local Prometheus instance that does alerting, or that does some sort of alerting, I'm guessing. Like,
Yeah.
Like the issue generally with metrics and queries is that observability tends to be like a distributed system, that it's like outside of that code base. Like, how does that work?
So the Prometheus runs outside of your, like it runs in your cluster, or it runs where your application is, and it.
Well, it's like if you're running like, say, Grafana Cloud, for example.
Yeah.
So yeah. So or Thanos or Mimir or whatever you're doing. Like how, like, because that's generally a kind of a difficult scenario or area to work in, which is like your observability software is somewhere here and that kind of thing. But I think like autometrics is kind of like moves the observability closer to the code and kind of does that in that way, I'm guessing. Or am I right?
It doesn't matter, right? Because you just scrape. You use Prometheus to scrape, then you save whatever you want, like Thanos, whatever. If I understood correctly, this is just a wrapper around the application, and they have custom agent that scrapes that agent and provides you like simple way to export different kind of the metrics, SLA, SLOs, like all the stuff you might need. So
Okay.
it's
Yeah,
just like different library.
It's a different library. No, you described it correctly. So it's like the library creates those metrics to an endpoint, and you need indeed Prometheus to scrap from that endpoint, storing the metrics in Prometheus. We also played a little bit around with the OTAL collector, so you can also switch that backend to the OTAL collector. But the nice part of the Autometrics framework is for us, or at least when we thought about it, is that you don't have to write the PromQL query yourself to get the request rate, the error rate, and the latency. So the library takes that logic for you in as well. And that's where we think that might be a sweet spot, so where we wanted to play around with.
There's also working at Fiberline. There's two benefits to it. Indeed, one is the fact that, well, actually it starts with one particular benefit, is that because we use function level metrics, so we take the function name and then for that function get the request rate, the error rate, and the latency. So we standardize on the naming convention. That means that now we actually know exactly what the PromQL query should be for that specific function. And because we standardize across that, you don't need to write all of these queries yourself, and we can build up these dashboards and the UI that you saw in the slides. But of course, also we have Grafana dashboards automatically created for that. And then you can start doing things like an additional benefit would be SLOs. So now you can also use sort of macros or specify your service level objectives based on these function level metrics. And if you do the SLOs, now you can do alerting as well. So there's sort of the additional, this is the screenshot.
And probably as a developer, you don't have to learn all the stuff about counters, different types of metrics using different libraries and export.
Exactly. So usually what happens inside of work, well, I mean, not to speak for every organization, but what happens is that there's a different team writing metrics for this service, and a different team perhaps doing for that service, and then a developer comes in and writes some customized metrics, and now you've got all these different metrics all over the place. This sort of standardizes everything, and it's just like one way to rule all the metrics.
But does that cover the inter-service communication?
Not so much inter-service communication. It's because we use the function level metrics. We do know the call stack, but it only goes sort of one level deep. So it's sort of tracing light, I would say. And because of that, we do know inside the service what the call graph kind of looks like, but between services, we don't.
Is there any plan to try to integrate Jaeger or something else into the stack?
Well, so it is OTel compatible. So you can use the OpenTelemetry collector. It is a good question. It would require a bit of a rewrite of the system, and to some extent it goes a bit against the goal of the project, because we actually think that metrics are extremely valuable, and logs and even traces are quite expensive to store. And you can do a lot if you instrument well enough with metrics. You can definitely have a lot of alerting in place that will tell you what is up, and then you can start going into deeper, right? So we actually kind of think that metrics are underappreciated as one of the key metric pillars. Thanks. But it's a hard one to get right. Sorry for hijacking.
No, that's okay. Yeah, I mean.
Just maybe, I don't know if this question, I try to understand more deeper how do you communicate them. I know maybe a theoretical question, but is it really possible? Like every team could have completely different, maybe not completely, but different metrics, and then to try to bring, like when you talk to each other, that they understand what you're talking about. Maybe the metric has a very similar naming, but it's still something different. And how to bring it under the hood? So you try, or you just live separately?
Well, it is quite hard.
That's-
There's different teams writing different metrics, right, and different names. Because it all boils down to effectively what you do is you write custom instrumentation code, right? And this library just standardizes on the naming convention, so it alleviates some of that problem, I would say. But indeed, if you got different teams writing different metrics, and they're actually not communicating, like people are not communicating with each other, it's quite a hard problem to solve. And what you see is like everybody's dumping these metrics into some kind of backend store, and people write dashboards on top of that. But then what happens, of course, the other thing that we kind of believe in is that dashboards are great, but they're great for the known knowns because you set them up in advance, and then reality hits, right? And it turns out that something goes wrong that you didn't really account for, and now you need to write a custom query. And who's responsible for that, right? Is it the SRE team, or is it the developer that wrote the instrumentation code that Nella talked about as well? So it is it's a theoretical thing, but it's a hard thing to.
I think it's not only theoretically, it's also organizational wise, because you want to give autonomy to your teams sometimes, and then you cannot enforce a certain tool. And if you enforce a certain tool in the library, you take away some of the autonomy of those individual teams of how they want to work with their services. So, yeah, I think that might be.
It's a very I think like a very interesting cultural field, right? Where we've got we went from DevOps to SRE to now sort of platform engineering, but you still have these sort of divide around sort of developers writing code and ops people or whatever you want to call them that maintain the infrastructure and the availability.
Same thing happens everywhere.
Yeah.
If you go into analytics, you have the same issue.
Yeah.
Teams talking maybe about very similar name, but they mean totally different things. Yeah, so we're not so far.
Yeah. Are there any other questions? That's good? Okay.
Sorry.
That's all I have. Okay, cool. Then, yeah, thank you. And do you want to?
Please feel free to carry on the discussion. I mean, it's break time now. We'll meet at 7:45 again for the next talk, which is by Guy. And thanks to Fiberplane again for refreshments, for pizzas. And thank you, Neela.
Thank you.
Love you. One housekeeping thing, guys. Please sign the attendee registration sheet there. Yeah? Thank you. was like, there's so many brilliant talks that don't make it to KubeCon, and it's nice to see that that adds value somehow, that you can actually, well, you didn't make it to KubeCon, so what can you make it to Reject? There's also 2-day conferences as opposed to a 4-day thing and travel budgets and all of that, so yeah. We had that free this time, so yeah.
I still need to see if comparison of probably parachuting, but I'm sure.
Will you be around for Salt Lake City later?
That's definitely good. Goal.
Yeah?
I should,
I see, okay.
although Salt Lake City is not high on my.
No, I was wondering because I know a lot of EU companies also have this, like North America, EU, which is a real audience, and which is of course a good way to go. But I don't know, somehow North America has it the other way. Like if we can, we make it to be why not, You always, I feel, for that reason, has good traction in terms of the size of the events, and Amsterdam was sold out. I was thinking about it for like much later, but I was like, if you didn't plan to. It would be nice. No, but then you can actually, that's why I was like, also talking about how projects can be. You also have, it's really very community focused, so it would be like, kind of, I think the biggest sell for that is that, hey, you get to speak to dumb people, or maybe, you get to speak to, someone else like Liz or someone like that, I'm probably more journey and, yeah, before KubeCon or something. It's good for that, I think it's more like to get that engagement going in person, because otherwise with KubeCon you can feel that things with them and stuff like that, it's so,
They're speaking of
that cool space where you can actually have FaceTime and you can have visibility for just something to think about, not pushing it out.
So you don't have basic at all. It's New Relic, it works like a charm, but it's extremely
I was
expensive.
like, technically it
It
should
was
be March, so
much cheaper
this is one exception.
when it was self-hosted solutions, but in Docker you pay for every container, and that's why we decided to switch to OpenTelemetry or Kubernetes.
But also wondering if we should, like, does it make sense to do something in the summer necessarily in an office space or somewhere outdoors? In summer it would be better. July, August is like, how many people coming to the office? Yeah. I want to be inside.
Actually, OpenTelemetry, I tried it, and for me it's like a better product. It's production ready, and they are asking about it, but actually the problem is it's right to install in my private project and to use for a different project manager because everyone started with 0.0 and I tried to include it and the result was the No, it's not the default method, and for each parameter they have its own configuration. For example, for Flask, it will be a Flask configuration plus the latest version of Flask is 3, and they support only Flask 2. That's Actually, I wanted to talk about Open Telemetry. At this moment, we use certificate for our own installation, and to check if they are compatible. And the answer is yes. But there are two types of propagation, and the difference fantastic. And they can use both of them. But I tried to integrate it into my Python code. For me, it's like very better because first of all, it tried to install the packages used while we used a different project manager, dependency manager for it. And next, my project had asked the third version, and the OpenTelemetry supports only the second one. And etc. So I need a lot of features, and I use very slow and speech. Yes, I know it's like integration, but even we don't use Jenkins, we use Elastic Search as a database, and we store scripts with a lot of downloads in one place. We use only the propagation standard. But we don't know why, because everybody is
Jedes Mal aber ich verstehe schon den verschiedenen Ziele von ich habe okay, Tuesday also, and then they just kept extending it. So it's like, what are you going to do if every time they have this right, you're going to change your meetup plans? You're never going to meet up ever.
It looks like it's similar. It supports the same it's different, it's not compatible. It's an alternative to new VPN, and it's free.
Especially in Berlin, you're kind of but then if you're coming outside of Berlin, then you're also you can have
I saw some slides from your presentation, and they are almost the same. I read it today for my presentation at my Yeah.
test them,
Okay.
verify it. You could have also lied and said, I tested it, it works. Nobody, but yeah, but at least, but here's one of them. No, I just don't. But it's a multi-billion-dollar company. You don't have time to verify one part.
Just a gentle request. Get seated. We're going to start a little earlier because the pizzas are on their way, but we also want to kind of continue on with the next talk so that we don't have to break rhythm while the talk is happening. When the pizzas are here, let's wait till the talk finishes and then break completely for the evening. Yeah? Does that make sense?
Pizza take the subway.
Well, maybe it tries to. Yeah. Yeah. All right, folks, we're starting a little early with the second talk, but the idea is to break at around 8:05. So for the second talk of the evening, we have Kyle Luca, and he'll introduce himself and talk more about his project and everything, but this is about deploying software and configuration in systemd context, and yeah, take it away, Kyle. And
Yeah, and systemd SysExt, and I'm Kai Lücke, a software engineer at Microsoft. In the Azure Core Linux sub-organization, and I'm mainly working on Flatcar Container Linux as a maintainer. So that's an open source project. It's a continuation of Core's Container Linux. And yeah, we are currently innovating a bit and making use of new systemd features, and I will introduce them to you. So yeah, I will talk first about why we are using these systemd features and why they exist. Then I will present them a bit, and I will describe how this systemd SysExt and convex thing is working internally. And I will give some examples and considerations on how you would use this. I will present some use cases, talk about limitations, future improvements, and give a small demo. So so why does this even exist? So the challenges we have in Flatcar Container Linux, for example, is that we have an image-based operating system. That means we don't have a package manager. But we have an AB update scheme where the whole OS is read-only. And now we want to customize this image-based OS with additional host-level software or configuration. And yeah, we don't have a package manager. And sometimes you also just want to deploy quick fixes or debug settings, maybe even ideally transient, without applying them to this so that you can be sure that they will be gone as experiment after the reboot. Yeah, and another motivation is that we want to manage these customizations through the lifetime of the machine. So maybe you have some config change, or you have a new software version and so on. And when you update, you want to make sure that it is like a fresh reinstall in the end. And the previous approaches that we had scattered files in /etc and /opt. And these were not easy to update, and they were also limited to simple changes to the operating system because you can't touch /usr as it's read-only. So all these binaries and so on can't be really well integrated if they are under /opt, for example, or you can't have config files apply to everything when sometimes it's only under /usr where the software looks for. So, and that's why sometimes we had to make custom OS image builds to really make deep changes. So that's also not a nice option. And I think it's also interesting to see that the current configuration management tools are often not very good at tracking old state. So when you have it, for example, you have your Ansible configuration in Git, and then you are checking out a new commit, you apply the changes. then you can easily be in a situation where the old stuff is still on the machine, but you don't know anymore, right? Because it's not in your Git state, and stuff is still lying around there, making problems. And so the wanted properties, to sum this up, are we want to have atomic updates where you are either on the new version or on the old version, not anything in between, both for software as for config. And then we want to have a reliable reconfiguration so that when we have a new configuration state that we want to reach, we can be sure that we are reaching this and don't have old stuff around. And ideally, we also want to have verifiable content. So when we have a lot of files on the disk, you can kind of try to make checksums and so on, but it's much easier when you have like one hash sum in the end where you know, okay, this is what we are having on the machine here. So now, what is sysext? It's short for system extensions, and these are file system images that create an overlay for /usr. So when they are loaded, files in this image appear as they were shipped under /usr originally, but of course they are not. And so that's an interesting concept here. And we also have the same thing again for /etc. So configuration extensions are like sysext, but for etc, meaning they bring, for example, whole configuration or parts of the system configuration in. And both are purely additive extensions. They are applied atomically at runtime, and you can also update them atomically because they are single files. It's like file system image files. And you can also use additional tools like dmverity for authentication and integrity. So that I don't know if you know this, you have a file system image, and then you also have this dmverity. It's like LUKS encryption, but just for authentication. And it's all in one image file in the end, where you have the signature then. So, and these extension images, they can come from vendors, they can come from users built by the sysadmin, and they can come from third parties, and they can either be bound to the OS version, so that's probably what the vendor will do when they are using dynamic linking and so on, or they can be independent from it. I will talk about this a bit later. So we have a disk image, that file that can contain a GPT layout. So as I said, optional with dmverity and the signature partition and so on, or just a plain file system image. And what's also supported is to have directory trees instead, or better with subvolumes. And for sysext contents, inside this file system image, you have things under /usr. And for convext, you have it under etc. And the rest of this is ignored. And these image files are expected to contain an extension release file, it's kind of a metadata file, to match for base OS compatibility. And all images that are available, they get loaded based on a certain folder they are looked for it. And then there's some version selection and so on possible on top when you kind of use symlinks, and then you kind of have a symlink to the kernel version you want to use, and then you can have versioning on top of that. So the bootloader can also pass sysext images for the initRD, but that's more like a special topic. But I just want to mention it here. And loading can also specify a stricter image policy. For example, if you want to reject unsigned extensions and say all my convext images, they should be dmverity protected and be authenticated against the keyring that you are loading and so on. So for system with sysext, these are the paths that you would put your extension images in. So it can be etc extensions or run extensions and varlib extensions. And for systemd convext, that can be run convext, varlib convext, and user lib convext. And then interaction can be done through this command line tool, for example. We have systemd sysext merge, that searches for all available extension images and mounts them on top of /usr or etc for context as stacked lower tiers in the overlay mount that is used then. And there's also a force flag to skip this compatibility checks that I mentioned with this metadata file. And unmerge gets rid of the overlay mount. And then we have refresh to combine unmerge and merge, and then we have new changes applied. And status and list shows like the merged extensions and the available extensions. But normally you don't have to type this. There's this systemd sysex context service that directly does the refresh for you on system load, like boot. And what's interesting is that instead of for the whole of your OS, you can also just use it in systemd units. So your unit can load extensions for their mount namespace and only that mount namespace. That means the rest of the system doesn't see this extension then. It can also be either extension image files or extension directories specified. And here's a small example where we have a git.raw file system image. And inside this image, we have the Git binary, for example. And then when we load it, it should show up under /usr bin git, but only inside this service unit here by specifying it with this extension images setting. And then we could, for example, make use of Git while the host operating system doesn't even have this. And you can also use extension images to bring changes into portable services. If you know these, that's also another systemd feature. So more into the details. So inside these extension file system images, to match for base OS compatibility, the extension has to carry this extension release.extension name file. And it's under usr lib extension release.d, and for confex it's under etc extension release.d. And the semantics of this file is like etc os release, if you know this, like a very simple format. But we have some additional fields here. And during extension merge, the image release file is compared against the base OS release file. And the fields ID and context level, sysex level, or version ID have to match. And there's also an architecture which should match if it's defined. But you can also opt out of this when you use ID any, for example, then your extension is compatible with everything. Or architecture any, and so on. Yeah. So, and we are also adding some new fields, for example, to allow for live reloading of services. We have this extension reload manager field now in the latest systemd version. And that will do the systemd daemon reload when the extensions are loaded. And so I mentioned binaries and how they are linked. So the binaries should only link to base OS libraries when you are like having a strong coupling through this version ID matching in the extension release file. And when the system extension gets updated together with the base OS, otherwise you have a mismatch, right? So, and if you can't really control this well because you're not the OS vendor, it makes more sense for you to have an extension image that is not coupled to the base OS. And then you can, for example, use static linking or a custom library path by compiling with this option. So here a small example now. We have an extension that consists only of 2 files. So it's a sysex image here that we have. And inside this, we have this extension release file, and myx is the name of our extension, and it contains this ID any to be compatible with everything. And then we just have one small text file for hello world. And you would put this under etc extensions myx as a directory extension instead of a single file system image. And then you are already done. Or you can use, for example, make squashfs to call it on this folder. And then you say output is this myx.raw file system image. And then you can put this in etc extensions and run systemd sysx refresh, and then your hello world file shows up. The same thing for convex now. You can, for example, think about a core dump config drop-in, so systemd core dump, for example, is running, and you want to say that it should only consider a certain process size for the core dumps. And then you have this my core dump.raw file system image where you have this extension release file again. Inside, we say ID any to be compatible with any OS ID. And then we have also this file that we can ship to tell systemd core dump to restrict the process size. And then we can load this when we put it under varlib convext and run systemd convex refresh. So some remarks. So extensions should be additive and not remove base files. You can do this with overlayfs, but it's not supposed to be used this way when you are having extensions. And if you don't update the extension in lockstep with the base OS, as I said, you should choose low coupling and rather use static linking and so on. And you can update your extension independently from the OS through any means. For example, you can do it manually. But you can also use the systemd sysupdate service. That's also a very recent addition. And it's kind of handy. I will show this later in the demo. Then, currently many early boot settings won't be applied because this extension loading happens very late in the boot. So, for example, if you want to customize kernel module parameters and so on, it's not working. So you need some workarounds. So, for example, you can set and run things explicitly from service, like helper service units. And for service activation, you can't really use the target.1 symlinks that you are normally using, but you need to use these target.uphold symlinks, which are evaluated by systemd even after the target is already running. And software in a sysx image can only bring files under /usr, and it should not rely on any files in /etc. And that means it needs to create them, for example, if it really has to be under etc. But it's much better if the software supports looking up for config files also under /usr, so you can put everything into one image. And so binaries and scripts, they can only go into a sysx image because by default, at least, convex mounts with no exec. Some more things. So when possible, you can consider to build extension images with DM verity protection and a signature, and then you can specify an image policy to only allow these signed images, and then your public key should be enrolled either in the firmware or in the kernel or in the user space keyring. And as I mentioned, we have this upholds systemd unit dependency. So how that looks like is that you create this upholds symlink instead of a one symlink under, like, in your extension directory before you package it up. User-lib, for example, systemd system, multi-user target.upholds, and then service is your unit. And that is a symlink to the unit file that you are shipping, for example, or another one that you expect to be on the system already. And then you also set extension reload manager in the extension release file to 1, and then systemd will take care of starting the service when the extension is loaded. So how do we make use of this in Flatcar, for example? In Flatcar, we have a generic image, but in the different clouds, you also need additional tools for integration. And we don't want to put this under /usr on the AB updated OS partition, but rather we had a OEM partition where these things were living on. And it was not really covered by the AB updates, and we changed this now that the vendor tools are also sysex images, which can be A/B updated, and they are coupled with the OS version and yeah, updated together in one step with /USR. And yeah, they kind of appear under /USR and are well integrated with the rest now. Another example is that yeah, we often have to balance between being minimal and the different user requests we get. So far, for example, Docker and Containerd are kind of standard in the base image, while other things like Podman, Kubernetes, ZFS are not. And currently, Docker and Containerd are shipped as an inbuilt system sysex image, so that you can easily disable this and bring your own. And in the future, we want to yeah, add more official extensions like Podman or Kubernetes binaries or ZFS, whatever, NVIDIA drivers to be provided as official extensions that are tested together with the OS when we release a new version. And then they are kind of pulled in when users want it and be part of these A/B updates. Okay, last one is user-provided software. So yeah, we ship a certain set of software, and users can yeah, also ship software either in containers or now as system-sysex images. And yeah, if they are not doing any dynamic linking, it's very yeah, easy to make sure that they can be updated on their own lifecycle. We have sysex bakery GitHub repository that has build recipes for custom Docker versions, Containerd, Wasmtime, and Kubernetes binaries. And currently it works by downloading the static binaries provided by upstream repositories. And we have these helper scripts that are very simple to download this and then package it up with SquashFS. And then we publish these sysex images as a GitHub release artifact, and they can be directly consumed through system.sys to yeah, keep them up to date. Another use case in cluster API, I don't know if you know about this, so you have a Kubernetes cluster then that can spawn up new Kubernetes clusters. And for each of these Kubernetes clusters, you want to have a way to update in place, because otherwise you have to throw the old cluster away, even if it's just a small yeah, security fix that could be applied. And currently it's not possible because this cluster API image builder, it bakes a custom OS image where all these binaries are put into /opt. And yeah, then the user has to load this custom image in the cloud and then can use this for spawning Kubernetes clusters and has to reprovision for updates. And with sysex, we envision that we can have in-place updates by also making it more easy to deploy clusters when we have it decoupled. So you can use the official vanilla cloud image-based like image from the marketplace, for example. And then on top of that, you can load extension images. And you can update these extension images on runtime. And then we have in-place updates with for KPI. So that's currently in work in progress. You can already use this in the OpenStack provider. Okay, so for user configuration, I kind of said that these convex images can either bring small changes or like your whole configuration that you want for the node. And it's kind of nice because then you have a single file that you can replace, and then reload this configuration extensions, and you don't have any old files lingering around. And it's also easy to discover because everything is in one file, and you can see what extensions are loaded. And then assuming that you didn't do any manual changes, you know that yeah, this is the only customization that was done, and the rest is coming from the OS as default. And as I said, yeah, you can also sign these configuration images and, for example, make them part of a measured boot to kind of bind a certain thing, like unlocking the root FS to the measured PCR values that the TPM can look for when loading these extension images. So some limitations and future improvement plans. So currently, as I said, the overlay is set up very late in the boot. We want to move this much earlier into the initRT so that you can make changes more easily, for example, for kernel module parameters and so on. And we want to add a small setting to explicitly restart services. We want to use the new Linux mount beneath API to make the refresh atomic in a better way, because currently it's shortly gone and then it comes up again. And so with the new kernel versions, it's possible to make this a bit nicer. And yeah, what we also were working on is to have mutable etc and USR mounts, because currently when you have extensions loaded, it's read-only. Your whole /etc or /USR is read-only. And we like that works for Flatcar, for example, but not on general purpose distros where you want to use apt or DNF to update your packages. So that's what we have merged in the last week. So only the next systemd will include this. Then you can make use of extension images easily on general purpose distros. Okay, so to sum up, system extensions have many use cases for OS customization. You can split out optional parts of in an image-based OS, for example, and also use them to deploy user configs. They are easy to manage and reliable to manage, and I think they unlock interesting security features with this whole measured boot topics and so on. Okay, so now live demo. So my setup here is I'm running Fedora with systemd development version, and it's now configured to have a mutable etc when loading extension images and a mutable /USR as well. And that's done. I can show you. I will just run these commands. So that's this new pull request that got merged. Wait a minute. I should make this a bit larger, probably. Yeah. Okay. Good. So we have this special folder here now, where you can say that when you load extensions, for example, /USR or /boot should be mutable. And then we can put any changes that are done in the overlay FS in this folder. And what we can also do is that we set up these subfolders to point back to the original etc and /USR. That means whether you are using extensions or not, the system will behave the same way. So any changes are done in the original directories, actually. Okay, and so then we have this config file where we can tell that systemd, context, and sysext should discover mutability based on these entries, and that's what we have configured here now. And my plan now is that I want to deploy the wasn't-time binary as a systemd sysext image, and I want to get it through systemd sys update. For that, I can download a configuration. So that's, I want to paste, yes. Okay, so that's how it's looking. We have this Flatcar sysext bakery repository where we have the systemd sys update configuration for wasn't-time. And I will store this into etc sys update.wasn't-time to make a new component. So we have a default component in sys update, that's the OS. And then we have any additional components, and because we are like independent from the OS lifecycle, with wasm time updates, we have a new component for that. We can take a look into this file if you are interested. That's how it's looking. Yeah, so we tell that new extension file system images can be found under this URL by having these wasm time version and architecture name pattern. And there's a SHA-256 sums file where all the files are listed, and that's how system.sys update discovers the files available. And then we tell that these extension images should land in opt extensions wasm time, and we have a symlink then set up in etc extensions to point to the current version. So, and I have to make sure, of course, that these folders exist. And then I can run system.sys update. There's also a timer unit that will do it, but I will do it manually now. Okay, and it's pulling up version 18 now, and it's installing it. And it's also setting up a symlink to the latest version here. And yeah, so we can look at how this was applied. Okay, yeah, so that's what we have now here as written. And currently I don't have wasm time available. Yeah, it's not there. And I will load this sysext image now. And I should have wasm time available now. Okay, yeah. And this wasm time extension doesn't ship much more, it's just a binary, so that's all I can show you now. Okay, but let's say I want to have wasm edge as well, because I know I don't have a sysext image for that, but it's available in my distro. So in the previous systemd versions, it was not possible to use your package management anymore when an extension was loaded. That's now possible, so I can install something. And through this overlay upper that we are using, which is the original /usr, all these different things that are installed now will land in the original USR directory. And I have, I have wasm edge available. And when I unload my extension images now with unmerge, okay, that was done. I still have wasm edge available, but I shouldn't have wasm time available anymore because that was an extension. Yes, okay, it works. So yeah, with this current in progress systemd improvement, you can use extension images on your regular Ubuntu, whatever you're using Linux. So, and with confext, we also want to have a mutable etc, as I said. The default would be to have a read-only etc for the after extension images are loaded. So what I'm doing now is I will prepare a new config extension, and it will be compatible with any OS, so it's not just about Fedora, but should work anywhere. And I want to have also this extension reload manager setting to make systemd reload all unit files when the extension is loaded. And the name of the extension is my network, because the whole point of this config extension image is that I want to enable systemd networkd. So, and as I said, we need these upholds logic now instead of .ones because our system is already running. And when you have systemd enable, it will create a symlink, and that's what we will do manually now as well. So here we have this symlink that we can use to tell that our multi-user targets pulls in this systemd network D unit. And then we can package up this extension as SquashFS, for example. Okay, done. And we can put it under varlib confx. And then we can say systemd confx refresh, and our extension should then be loaded. Okay. You can see that this is now loaded. My network was the name of this extension. And it's taking upholds. Yeah, okay, we see that's working. Yeah, so that's it. The last part of the demo.
Let's just say.
Done.
Just wrap up, yeah.
Okay.
We're a little past time, but if you have any, if anyone has a quick question, and then you can take the discussion, of course, while you're having pizza and drinks. If anyone has a quick question for Kai, go for one. As quick as possible, I realize it's relative.
You can also do it there.
It's a very
Yeah.
complex topic.
Yeah.
So.
Yeah,
I have a question, but it's not quick.
I mean, what I can suggest is combine maybe just share your comments, and then Kai, you can just kind of put it all together and share some last thoughts, and then take the discussion forward at break. Any thoughts?
We can also do it in the queue, other.
My comment is, I think it's very interesting and a good replacement for user data scripts and all that other horrible things people do to configure OSs on boot. So, really
Yeah.
good stuff.
So quite in progress, but I hope you get the idea. Okay.
Anyone else?
I'm plugging this.
Now that I said 2 minutes, that took a few seconds. You see the conundrum I'm in. Yeah? All right, guys, you can also continue to discuss that over pizzas and refreshments. Thank you so much. And this is it for this meetup. We'll see you again on 17th of April. And if the date changes, you'll hear about it, of course. You'll see the event page.
These extension images that
Thank you
you're
so much,
talking
and
about,
have a lovely evening.
how are they actually built?
I built one,
Okay,
with make SquashFS.
yeah.
I just packaged up a folder, but you don't really have to do this. You
Yeah.
can also use the folder directly and move it there.
Okay, so it's just like placing files and then just,
Yeah.
okay.
And then you can kind of manage this, you can remove the folder and put a new version of this folder.
Yeah.
But it's kind of nice to have everything in one single file,
Yeah,
so that's
'cause-
why we use this
Yeah,
SquashFS
because you were
stuff.
talking about all this library or extensions that were.
Ah, okay.
operating, and
So
I
that
was
kind
like-
of building.
Yeah.
Yeah. So there are compiler options you can use to make a static binary or to have a custom library path. You can also post-process binaries to use a custom library path.
Yeah. Okay. Yeah. That was kind of what I was like.
Yeah,
kind
so
of- and
that's
all
the
this is,
tricky part, yeah.
And all this is really interesting because, as I stated, all the cloud init stuff that people are doing with figuring out how to slightly customize base OSs to do small things instead of building separate AMIs or whatever. I think it's
Yeah, so with Cloud Init, you can kind of bring in this extension image, and then
Yeah.
you have an easier way to keep track of
But
the
I
changes.
think in a perfect world you would have solid APIs where you could define extension
Yeah,
images and then-
but it's not currently easy.
No.
With every cloud doing it different, and
Exactly.
then you end up only having Cloud Init as common base or something like that. Right?
So those extensions are just binaries somewhere, and the engine for pulling them, it's built in the systemd, right? So
You can also copy them as you like with SSH, for example.
but there is already built-in system, right? So
Yeah.
systemd pulls them. Like
Yeah, you can use the system update thing to download these extension file system images, and inside these, then you have your stuff. Yeah.
Yeah, exciting things, yeah.
But basically, is mounting the overlays on top of everything, like
Yeah.
hiding the stuff. It's a quite clever way.
Yeah,
just
so
thought
it's
about it.
merging things. Yeah. So the idea is not to you can override things, but ideally you have no conflicts to
I mean,
prevent any confusion.
overwriting things might be good, like if you have huge clusters and you need to read worker nodes, right? You don't have to evict pods and like factor plots and all this stuff. I mean, neither of those should be fine, right? We're talking about cloud native stuff, but there is always applications that have issues with props and stuff, and
Yeah, that's why they think about mixing the stuff, like making them writable, because otherwise, yeah, it's kind of made in stone. Yeah, definitely. But still a nice idea.
Yeah,
If you ask me, I mean,
it's amazing.
at least comparing to all the other open source stuff that we all know how there are like hiders like everywhere. Some putting stuff in etc somewhere, and yeah, I used to administering before like a lot of stuff in Linux, so yeah, it's kind of no standards there. I think for me, at least for me, the different distributions they put things everywhere. So it's this approach will handle this.
Yeah, it's tricky. Some software doesn't support looking for config files under /usr. Then you have to have a helper unit to create a file under etc or whatever, and then it's happy the software to run. And, yeah, even with just the symlink back to /usr. Yeah. So some tricks are needed. Yeah.
I wanted to ask you, what is the motivation of your team to doing this? I mean, what would be the use case?
I mean, in our case, we are doing this operating system, and
I mean, because this is what I saw. I mean, it's still on early stage as far as I can get, or I mean.
yeah, kind of, yes. So I said there are some future improvements that would be good to have to make it really nice, but you can already use it.
What is the difference between, let's say, because you also use Fedora for example, but what's the difference between Fedora Silver Rule? I think it was their kind of implementation of immutable system, because actually they have kind of immutable base image, then you can put stuff on top, but you can easily remove it. Like
Yeah, this is
RPM
RPM OS3 integration, yeah. But it's not really for user changes. So like you would have to build an RPM package to, yeah, but I mean, who does that in the end, right?
But I mean, the idea is to be kind of the desktop operating system.
It's more for servers, I would say, but yeah, ideally, I would say it's generic enough to be useful for the desktop case, because, for example, GNOME OS is using this now in the new development version of GNOME OS to lay over NVIDIA drivers, yeah, to keep them out of the base image and have them layered on top if people want to have it. Or GDB debugging tools and so on. Not everybody needs them, and then they are layered on top of the read-only base image.
Okay, thank you very much.
Ne?
Like I used to host a lot of meetups and
Zu deinem Talk. Also du bist jetzt von Microsoft? Oder?
Genau, ja.
Und ihr seid jetzt das Team, was noch bei Kinfolk mitgemacht hat? Oder?
Ja, es waren quasi mehrere Teams, die es auch noch gibt im Moment. Andere machen eine Kubernetes UI, die heißt Headlamp, und wieder andere haben vorher so eine Kubernetes Distribution gemacht, die machen sie jetzt nicht mehr, sondern machen eher so ja, Cluster API Upstream Sachen.
Aber es ist jetzt, also ich habe das so ein bisschen mitbekommen, wie Kinfolk dann da so drauf wurde und so, aber
Also für uns hat sich jetzt nicht viel geändert und wir machen Flatcar und das machen wir immer noch so. Ja.
also das war der Hauptgrund für Microsoft, dass ihr weiter noch Flatcar.
Nö, ich glaube, das war einfach so eher, also wir haben noch ein anderes Team, das macht Inspector Gadget, das ist so eine Toolbox mit eBPF-Sachen und genau, ich glaube einfach dieser Mix von verschiedenen Themen war halt interessant, weil bei Microsoft die Leute ja keine Ahnung von Linux haben und deswegen, ja.
Immer mehr.
Genau, und das hat sich halt jetzt geändert und dann wollten wir natürlich irgendwie, ne, wenn man die Möglichkeit hat, noch mehr Leute zu kriegen, das auch nutzen, und hat sich auch so ein bisschen die Kultur geändert irgendwie, ne, dass man probiert, Open Source besser zu verstehen oder Communities zu verstehen. Das ist halt ein langsamer Prozess, aber da kann man gut zeigen, wie das funktioniert, auch Remote-Arbeiten.
Hast du Probleme mit? Nee, aber